Hello everyone, this is Matthew, and today I thought that I would do something a little bit fun. Well, actually, I had just kind of helped show my friend Ashton how to do some surface mount work, and I thought that it would be, but I did a really bad job though. I mean, really, didn't have a good opportunity to. I just didn't really. Well, I just didn't do things the best way. I'm going to turn off autofocus, so we'll have to see how that works. Anyways, I also thought it would be fun because I've really kind of gotten into using Open Broadcaster for things like Twitch, and I thought that this would be a great way of getting some really good angles and other sorts of stuff when I'm explaining things, to give you guys a really clear view of what's going on. So I've got a couple of different views here. I've got this overhead view. I've got it where the overhead view is just a little bit zoomed in, digital zoom, but you know, what are you going to do? I've got a microscope view, so we can actually see the work. It's not the best quality in the world, but yeah, we'll see how that goes. Also, just let me go back to this full view. I don't know if you guys can make this out or not, but that screen that normally shows me what it is that I'm about to be doing, it's not showing me anything. So I'm going to be looking over my right shoulder at my laptop because that's where my laptop is. A very inconvenient spot to actually see. So please be gentle. I will do my best, but there's only so much that I can do, right? And then there's also a front view here, which is on the older camera, but this will let me show you guys a bit what I'm doing with the hot air rework station. This is a little cheapie from Amazon. I think I spent 50 bucks on it. Definitely don't want to use it for motherboard repairs or any kind of repairs on things that have massive back planes with multiple layers in the boards, because it just won't do the business. Like, you might manage it, but it'll suck. So my advice, buy a proper station if you're going to do proper work. But yeah, so those are some of the views that I've got here. So real quick, let's just go over some of the stuff that you're going to need if you're going to start to do surface mount rework, or not rework, but just surface mount work in general. So the first thing is you're going to basically need some of the stuff that you would use for if you were soldering your through-hole components. Now, if you're not really familiar with soldering through-hole components, there will be some good parallels, but in reality, you should probably do one of those classes or look at one of those videos online first and get a really good feel about how, and then actually build some kits, do some of those things. Like, this is a kit, in case you guys haven't seen kits. This is a pretty complicated one, honestly, but it's a classic. It's not too bad, but it is a classic. This one's a radio. This is a very good kit. Ellen Co. makes some really amazing kits. They're kind of an older group, older brand, and they do make some really good kits that explain the circuitry to you. So make just some simple dinky kits. Don't start out with something like this. Get some little flasher circuits. They're called they call them like multi-vibrator circuits, and then basically that just switches a little LED flasher back and forth. Get some of those, get stuff like that. Practice your through-hole soldering. Get used to heating the pad and the lead at the same time, stuff like that. And then once you get that down, just go for it. You know, surface mount soldering may seem pretty daunting at first, but in reality, there are some interesting things about it that you just don't, you wouldn't guess to be so unless you try it. A good example of that is that you look at the teeny tiny little parts and you say, well, my hands, they're not incredibly steady. Well, your hands will get steadier, and they'll especially get steadier if you have good magnification, because you'll get the feedback that your hands, that you're shaking or something like that, and you will get down to the point where your hands are very stable um, in a surprisingly fast manner. You really might not guess that, but just practicing on it for, you know, a week, and your hands will be way more stable, and you'll lighten up off of your death grip on all the little components, and things will just kind of fall into place. And then after that, it's going to feel a lot like your through-hole soldering. So really do give it a shot. So, but yeah, component things that you're going to want for doing soldering, for surface mount soldering, is you're going to want a good quality flux, or a good quality solder. Just a good quality solder, like Kester solder or motor solder or something like that. Make it a nice lead-based solder, then make it a fine solder. Like this is even a little bit thick for surface mount stuff. I mean, you could use a little bit thinner and you'd be better off. Because I mean, if you look at this, let's switch over to the microscope view. So we're looking at, let's look at this chip here. This solder is pretty damn big. You wouldn't guess it, but it's pretty big. It doesn't need to be as small as these pads or anything like that. The surface tension will suck the solder to the pads, especially if you're using flux, like you should be. But if you think that about if you were using a thicker or like medium thickness solder, then you would absolutely just be doing too much. You'd have too much solder on the pad. So make a good, thin, high quality solder, and that'll make life a lot easier. If we look, we also want flux. It can be from a flux pen. It could be a flux syringe. I like the syringes when I'm doing surface mount because it lets you get right in there. Try not to get flux that's too solid, because flux that's really jelly can be really difficult to squeeze out. So like this is a very thick flux from MG Chemicals, and it can be incredibly difficult to get out because it is a no clean flux paste, and the gels are much better. And so, but just make sure you have a good flux. It really is the secret to doing good surface mount work, because it'll make everything just glide into place like magic. You're going to want some good high quality tweezers. I got these particular tweezers from they were being sold by Hakko. I don't know if they're from it, but they're all solid, or they're stainless steel. So they have a really low ability to become magnetized. So really nice there, and then really nice fine tips. If we go back to our microscope view on that chip, you can see that the solder, that these tweezers, even though they're super fine, I mean that is pretty big compared to a chip, or even more so it's obvious when you start to go to the surface mount parts. So like this little surface mount part here, this is a very small one. This particular size is I think that this is called, I think this would be an 0402 or something like that. Very small. These are the ones that I'd recommend you start with. These are going to be 0805s. These are basically saying that they are, they're much more usable when you're first getting started. To put into perspective just how small this surface mount device is, let's grab something for scale. Let me find like a penny. I might not have a penny. I might only have a quarter. Or is this oh, I got a dime. Okay. So let me show you a dime. next to these parts. So this is a dime. See? So I definitely recommend that you start off with the bigger ones, because this is manageable. I mean, that's pretty manageable, and all of these are pretty manageable once you get used to it, and if you have decent magnification. But start off with a little bit bigger if you can. They sell kits that are very simple surface mount soldering kits. They don't even do anything. It's just a bunch of parts like this and a bunch of packages. They'll have chip packages, they'll have all sorts of stuff, and just a lot of it, and all the parts you need. Just get those, practice the soldering there, and then, you know, once things you're comfortable with it, definitely go for things that you can build, because it's amazing how much satisfaction you can actually get out of that. So you're also going to want, if you're doing any kind of soldering in general, I'd recommend to always have a good high quality solder braid. Desoldering braid is one of those things that is really useful, but it's extra useful when you're doing surface mount work, because you have to think you're not going to have any through hole components. So, and doing a solder sucker is just going to suck your part right into the solder sucker. So if you make any mistakes, you're really going to go to either just a blob of solder on your soldering iron, or you're going to go to the solder wick. So definitely recommend picking up a good high quality brand. Don't do Radio Shack brand. That's what this is. I just needed solder or desoldering wick, and I had plenty of flux, so I thought things would be fine, and it's been fine. But yeah, just a good proper solder braid sucks the solder up wonderfully, because it really has a good coating of flux on it, and this Radio Shack stuff just has a really thin, not so good coating of flux. So yeah, want some of that. And oh, right, so something that's really useful to have, and I'm not sure if I've already covered this a little bit, but we'll go back anyways. So here's the front view. Is you'll want the hot air station. You want it to be decently, you know, powerful enough. Let me just give you a quick walkthrough over hot air stations in case you haven't used them. So hot air stations are fantastic little devices, but they most soldering or hot air stations, you're going to have a couple of ways of adjusting things. So they'll probably all basically have some combination of control for the airflow. And on my particular one, the airflow is just a little potentiometer here. Just goes from 1 to 9 or 10 or whatever is on the other side there. And most of the time I use it on either all the way, or I'll use it around 5 or 6. And I'll explain why I use those, that kind of speed and airflow shortly. And then you'll have some means of adjusting temperature. This particular unit is in Celsius, and you'll see it starts heating up, and I can adjust the temperature with this, and I can adjust the airflow with this. These are also really handy for doing heat shrink tubing. So something you'll probably notice there is that when I took this off of the stand, like I was going to work with it, it turned on its own. And that's great. The reason why this is important, and something that you'll see in most hot air stations, even the cheap ones like this one, is that hot air stations, or that the hot air guns really need to be able to turn themselves off. But turn the heating element off, but leave the actual fan running for some period of time to cool off the element inside. If you don't have that, then you just shut it off like this, you will end up burning out your element and it won't last. So you want it to be able to tell when you're holding the hot air gun, and you want it to basically turn off the heating element. You can see this is counting down, but remain on so that it can cool it off to a certain temperature. So that's important. A lot of people, when they're first starting out, they'll put it on here and they'll say, oh, I need to turn it off now, and they'll turn it off, and then their heating element will die quickly. So yeah, just let it run through its course as it cools down. When it's ready to be shut off, it's going to shut itself off completely. That is on most stations. Mine displays dashes when it's turned off everything, but is still like in standby mode. Also, you're going to want a normal soldering iron. I'm using a little Hakko soldering station, but it doesn't necessarily have the best tips for this or anything, but it works. So yeah, the only thing you really need to start is just a good soldering iron, some good tweezers, some flux, and yeah, some little test boards to get yourself going on. So I'm going to turn on the Hakko here, because we're going to start using because we're going to start doing some soldering. So and then surface mount some kind of magnification. So I'm going to switch over real quick to this view. So this is just a board out of a Logitech headset for like office phones. This is for the base. And I got this from work just as a little test thing for showing my friend Ashton how to do surface mount soldering. Sorry. And we're just going to use this as our little test device. So let's switch over to the microscope view. Apologize in advance for the kind of crap microscope. Let's go for some nice beefy devices, some nice beefy surface mount components to start off with. These are, I'm not entirely sure what size this would be, to be honest. They're a bit bigger than most surface mount things that you use these days, but they'll be great for an example, to get us started. You can see next to the tweezers how big these really are. Something I forgot to mention that I think that is also really useful to have and important. There's actually two things. Let me go back to this view. One is gloves. Now, flux is probably not that. It's not horrible to get on you. It's just a little bit mildly corrosive. It's just really sticky and gross. So I recommend just some disposable gloves, because it's really hard to get flux off your skin. You really almost have to use a solvent like isopropyl alcohol to get things going, but or to clean things up. But even that, I'm not entirely sure how good that is on your body, just because you're then thinning out a corrosive and toxic material, and I'm not sure if that can just be absorbed in your skin, that kind of thing. Either way, it's a good thing to keep in mind that gloves just will make life easier. I mean, you won't notice just how much flux you actually get on the gloves until you aren't wearing them, and then you'll get flux all over yourself. Next thing that's super useful that I said I had forgotten to mention is lots of isopropyl alcohol. Did you see that? Sorry, let me just switch over. So the thing turned off. It's doing dashes now, and it didn't die. So that's a good thing. So sorry, but yes, alcohol. Lots and lots of high concentration isopropyl alcohol will make your life a lot easier. I'm using just the 91%. It's actually on top of just being really good for dissolving the flux and all of that, which you're going to want when you're dealing with your little tweezers and stuff. It's actually really good for troubleshooting, to finding shorts on boards. You just inject a little bit of power, and then the device that's shorted will heat up. You spray some isopropyl alcohol on top of it, and then the part that gets hot, that's shorted, will evaporate fast, and then the rest will still be wet. So it's actually a really useful thing to have on hand. I also have this is just a little tray that you use to collect screws and stuff. I also have a little tray that I put some isopropyl alcohol in, and I use that to kind of clean my tweezers in, because your tweezers will get very gummy and want to stay stuck together, and it'll also make it very difficult to adjust your components that you're working on. So I recommend just giving yourself a nice little bit of isopropyl alcohol inside a little tin. Doesn't need to be nearly as much as I put in there. I put in way too much. And just occasionally give your tweezers a little bit of a dunk and cleaning, and it'll make things a lot easier. You can also even dunk the little component in there with it, and then it'll clean it off, and then it'll make it a lot easier to move around and stuff. Heat also makes it a lot easier, or better yet, gel-based flux versus paste-based. So anyways, let's go back to the microscope view, and we're looking at these components here. So there are a couple of things that we could do here if we wanted to remove this component. The easiest is going to be using some flux and then our hot air station, and I think that's what I'll do for the first one. Not actually for the first one, I will do kind of the just normal solder station method. So this is a big component, and it's going to be a little bit difficult to do this. But if you have a component that's bad on a surface mount board, you can do it's like the caveman 500-pound, 900-pound gorilla thing. You just take your soldering iron, make it nice and clean, come in, and then just flood all kinds of solder onto the pads and stuff. So by that I mean really go at it. And then you can just go like this, and you'll see you just pull the thing right off. This is a really useful thing to do. Just know that it can and often does hurt the components. So just keep that in mind. But you'll see that even just using the little surface tension and stuff from the solder, it just sucked right to it, and I ended up having one second here, let me just get that hot, and I was able to just pull that right off. So if this part was bad, we would have been able to remove it, and then we would have been able to work on our pads and make them nice and clean, and then put a new part on. But something I didn't do here that, again, you don't really have to do it if you move fast like I did, but putting on a good glob of flux there would have made life good. So you can see there is still quite a lot of flux on the board, and this was caused by all of the solder with the flux inside of it that I flooded into the spot. But more flux is almost always more better. That's just kind of how it goes. So that's one way to get components off of surface mount. Just keep in mind that anything that's even remote, anything that has any kind of phosphor, like an LED or something like a transistor, that's probably going to end up killing it. So only do that if the part's bad, or you need to practice or whatever. So all right, so now let's do it this time with the hot air station. You'll see here, I'm just gonna switch over to this view real quick. So I've got my my solder flux here, and it's the paste kind, so it's very difficult to syringe out. By that I mean, if you look at how much force I'm going to be putting into this, I'll use my right hand even. If you really squeeze, it'll start to come out. But it takes quite a bit of effort, especially if it's been sitting. So just keep that in mind. Something that you can do if it's been sitting and you've got and it seems really stuck up and it's really hard to push out, you can just kind of take your hot air gun and just kind of heat it generally, right? You're not wanting to solder the thing, but just kind of heat the tip and then of the syringe, and then it'll just start dripping right out, and that'll help you out. So I'm going to put this back on the station here, and I'm going to switch back to the microscope view. So that's some of that solder that I put on. The next part that we're going to take off is going to be this this resistor with the little glob on it, right? And we're going to give it a good amount of flux. More flux tends to just be more better. Like, this is probably a reasonable amount of flux, but if you like go all hog wild like this and just really give it some flux, that's okay too. More flux is just going to make it better. It just is. So trust me on that one. It's a good way to kind of make up for things if you're not that good at soldering, which, you know, we're going to be working with teeny tiny little parts, then that's really useful. So this time I'm going to take out the hot air station, and I'm going to switch over to this view so that you can really see. Now, what I'm going to do to begin with is I'm just going to heat the general area. The idea here is that we're trying to reduce the thermal shock on the board. And then after heating it a little bit like this, we should be good to switch over to the microscope view and actually look at taking the part off. So I'm going to use my tweezers. I'm actually going to take this top one off because it's just a more convenient way of grabbing. So you see, I'm just going to kind of get close to the part, and you will see it's just going to start to smoke. And then once the solder starts to melt, the part should just lift right off. All right. So we've got our part off there. But we'll do this other one as well, and I'll just kind of reposition things. And sorry about the strange view, but it's the best I got at the moment. So you don't want to go too fast too quick, because you don't want to, you want to reduce the thermal shock, but you can see that part came right off. And because we heated it a little bit more gradually, we've kind of eliminated the issue with not eliminated, but we've made the sudden thermal stress a lot lighter. So now that we have our parts off, let me switch back over to microscope view. Now that we have our parts off, we should be able to prep the area for additional parts. So real quick, you'll notice this is stuck, and as the solder cools, or the flux cools down even more, it's going to get more and more sticky. But you can see this will basically stay in any position that I want it to, just without any pinching on it at all. And you can kind of use that to your advantage at times. Like you can kind of set it down, but you'll see it's very difficult to maneuver this because it's a sloppy, goopy mess. And that's okay on the board, but we don't necessarily want that on the tweezers and the part, because it just makes it difficult to position. So that's going to be kind of where the alcohol, a little bit of alcohol that I had mentioned before, comes in handy. So if we just kind of take the part and put it in, you'll see pretty soon it'll just kind of fall off, you see? And alcohol is really safe on most electronic parts, so they actually use it as a washing process on a lot of the parts, but you can see that now it's not so sticky, and you should be able to actually lift it off. And now that it's not so sticky, I'm just going to handle it a little bit with my fingers. So I'm just going to set this off to the side, this part, and then we are going to use this part to after we prep our pads for new solder and all of that. So I'm just going to stick it back in, and I'm going to take the other two parts, the other two resistors, and this one's it's kind of stuck. If your part gets stuck onto the board, just take your hot air gun, give it a little grab, and you'll see that what that really was sticking there was just that flux, and it didn't take much to take it off. But then we can go like that, and I'm just going to set this stuff off to the side for the moment. Kind of clean up my tweezers a little bit, and now we're going to prep these pads for additional solder. I'm going to grab just something here to kind of prop this up. One second, guys. There we go. All right, so now we're going to use our normal soldering iron. Going to want the tip nice and clean. And what our goal of this next part is we want to take all of the non-lead based solder, and we want to kind of just get rid of it, because beyond the fact that it's harder to work with, it's also when you start working with surface mount parts, they're so close together that there can actually have a very unique failure, which is where what's called tin whiskers form, and that's where the two patches of tin try to grow together. And occasionally that'll happen on the really fine parts that deal with somewhat higher voltages and stuff, and then it'll short out and then it'll cause damage. So we want to kind of get rid of that. The way that we're going to do that, though, is we're just going to give the area a nice bit of flux. You see we've got flux glob everywhere. We could either, there's a couple of things we could do. We could either squirt more flux on, or I'm just going to do this. I'm going to take this wire, and you see there's lots of it that's kind of blown away and stuff. I'm going to kind of just dab it on. Give it a nice gloppy, goopy mess of flux to work with. And since I'm using the solder, or solder, and it's more properly said, I'm sure, we can now just kind of, we're going to make a big ball of solder, and we're just going to scrub over the top of this whole surface. So, see, I've got my tip here. I'm just going to make a nice ball, and I'm just going to kind of go like this. I'm going to flood over those pads like this. I'm going to keep adding more solder, and I'm going to take this and I'm just going to flick it off on the table, or wipe it off on my little pad there, or my little steel wool style thing. So like real quick, let me just show you what I was meant by it, flick it off on the table. So I kind of went like this. I took and I flooded a bunch of solder on, you see, and getting a ton of solder on there. And now, since I've got all that non-lead based stuff inside, I'm going to take it off. I'm just going to go flick and kind of get it off the iron. That's just a good way of kind of getting rid of excess solder without making the thing that you're cleaning your tip on too crazy. So now that we've got a decent amount of solder on the pads and it's the nice lead-based stuff, I'm actually just going to clean it using the solder wick. So let's go back to microscope view here. And you see we've still got this nice pool of solder, and you can really see it covering everything. That's beautiful. This is going to make our desoldering wick process just beautiful. So I'm going to take my soldering iron and I'm going to push down on the tip on the pad. I'm going to move the soldering iron and the wick together. I'm going to lift them together. This is important because when you start working on surface mount things like this, you run the risk of pulling the pad right off. And you can see that left a nice, beautiful, shiny new pad. Again, this is just to really clean this pad and really get rid of all of the excess and non-lead-based solder that we've got going on. And I know it's probably, you're like, well, people use non-lead-based solder all the time. What's the big deal on that? It'll make your entire surface mount soldering process like way worse. It'll make it just really difficult because it basically, it just doesn't have the same like characteristics and flow of lead-based solder. So you kind of end up with this situation where it doesn't like to flow the part into place nearly as easily. And working at home, you know, we just kind of want to make things as easy as we can, or just working in general, right? So now we've got these nice, beautiful, clean pads. There's a couple of things we can do, but from this point on, if I was working on on smaller components, I would probably at this point be tinning the pads, and then, because a lot of the times the actual pad of the component is on the bottom and it's not really on the sides at all, and we'll actually do that here. And it's a little bit more difficult because we don't want a ton of solder. We just want enough to really give it a good bridge. I mean, to give it a good connection. That's easier to do on the smaller pads, really. But we're just going to solder little blobs onto these pads. So basically, we're kind of just undoing what we just did. We're just kind of giving a little bit of a dab. And you can see there's a lot less solder here. And because we've got that nice, beautiful flux on it, we can kind of move back and forth across our pads like this to kind of evenly distribute a nice dome of solder. So I know it's hard to see with all the flux on this part. So let me I'm going to turn down the light because it's got a little overhead light on this thing, and it'll help you see things quite a bit, I think, but it's also going to be a little bit darker, so you'll have to bear with me on that. Okay, so now our pads are all prepped and tinned and ready to go. So there's a couple of things we could do past this point. We could use our hot air gun to basically flow the part into place, or we could use our soldering iron to solder it onto the pad. And I'll show you first what you would do with the soldering iron, since you're probably going to have that for sure, and you might not have a hot air station. So let's take that part, cleaning off my tweezers. Every time you hear that noise, that horrible, awful noise, that's going to be me cleaning off tweezers. So we've got our surface mount part here, and you can see it it'll let go it'll let me kind of position this, and since it's not so sticky, it's going to let me position it in the sticky resin. And so you see, I can just kind of adjust this and position it. That's what you would do, just getting it ready like that, if you're going to be using your hot air station. But assuming you're working with a smaller component, or you're just working without a hot air workstation, you would just hold onto the part, take your soldering iron, make sure you have a nice amount of flux around, because you don't want to carry solder to the tip or to the part. You want because then it'll be dry normally, so you want lots of flux to fix that problem. So you see, I'm just going to position this. I'm just going to touch the side, and then that's tacked on, and then I'll just do the other side, and that's soldered down. It's not very flush with the board. You can kind of push on the part, and then kind of, did you see how it set down? You can kind of do the same thing with the other side, and depending on how small your part is, it might just kind of work its way back and forth. But you see, we now have a nice soldered part on there. Maybe a little bit off to the side, but you know, that'll actually flow into place when we start to do the hot air station. And that's really the advantage of doing a hot air station, is when you start working with components that are small and light like this, the actual surface tension of the solder is enough to do the work for you. It'll pull that part right into place most of the time. So let's do this with the hot air station now. So I'm going to give it a bit more flux, because I want a nice gooey, sticky, gross surface for that to go in. And I'll grab this other one. I'm going to clean those tweezers again. Alright, so I've got this part, and I'm just going to kind of push it down and set it into place. Come on, yeah, there we go. Doesn't need to be perfect. Even if it's a little crooked, actually let's make it extra crooked, just to show what I mean. Because this is going to really suck right back into place, and we're going to make it dance a little bit with our hot air station, and you'll see what I mean by that. So this is the situation. I think I had mentioned this, that I tend to use my hot air station on a couple of different speeds for the air. I do somewhere around 5 or 6, and I would do full blast. So I'll do full blast if I'm trying to heat up the large area, or if I'm trying to remove a lot of components pretty quickly, kind of replace an entire area because something's damaged. We'll say water damage. But it blows away the flux quite a lot, and it also blows parts away. So like if I was to do that on that part right now, it would just blow it right away. So because I'm installing the part, I'm going to turn this down to about 5. So I'm going to go back to my microscope view here, and I'm just going to kind of heat up the area. I'm probably 4 or 5 inches away from the area. I'm just kind of heating it up slowly with my soldering iron. I think you can probably see the flux starting to melt a little bit. And now I'm just going to kind of come up over the part, and you can see the soldering starting to melt on that one. And now if I kind of wiggle the soldering, or the hot air station back and forth, and did you see it suck right into place? Now we can do the same thing with the one up above it. Did you see how it centered that off? So that's the real advantage here. So you can go in and you kind of poke it and center it up even better. You see how we're making it dance. We don't want to do that too long, because we don't want to fry the part. But now that it's centered up nice, we want it to be flush if at all possible, because that's how it'll dissipate its heat and stuff. So I'm just kind of pushing gently on top of it with the tweezers. Now I'm going to come back in and I'm going to melt that solder again, and you'll see it set right down on the board. And that was less dramatic than I was expecting it to be, but I think it just sat down really. Oh shit, it's still hot. Oh, see, look at me fucking it up. So we'll make it dance, push it down. Okay, there we go. So we have that part nice and put in place. So now, if we wanted to, we could cool it down with some alcohol. I've got my part here, and you can see it just flashes right off and right away. But every time you're doing that, it's really cooling it down. You can see how it's slowed down. Now it's not that hot. Now this isn't something that's super important on resistors, because resistors are kind of meant to be able to go hot, not just in the manufacturing process, but so because they dissipate heat. They're like little heating elements essentially. But if this was a silicon component, then cooling it off quickly like that is a much better solution than letting it stay hot for too long. So we've got those two nice and soldered back on. Let's move on to some other parts that are smaller. So like these are the largest surface mount parts on the board. I think they're the largest surface mount style that you can buy, generally speaking, like for general use. Let's move on to stuff that's a little bit smaller. Actually, let's move on to stuff that's a lot a bit smaller. So let's see here. So this is what we, sorry, there we go. This is what we've been working with in size. So let's go down here. And as you can see, there's a lot, those are a lot smaller. Those are some of the smallest ones that you're going to come across most of the time. Again, when I say the smallest ones you're going to come across, I'm really talking like general, everyday kind of work. This definitely sits down nicer on the board. So I'm going to turn up the light a little bit. So how would we go about replacing these? Well, basically about the same way. It's pretty much the same process, except now you can see our tweezers are considerably larger. I mean, this seems gigantic. And also, let me just show you this. You can see how the paste is very sticky, and it's making it click, and it's making it difficult to maneuver. This is a huge problem when you get to parts that are this size, because this size of part is a very small part indeed. So first off, I'm going to clean these tweezers in the alcohol. Sorry about that awful noise. I'm sure it doesn't sound very good. I'm actually going to take one of those. I'm actually going to, here, let me do this. So I've got the thing here. I'm just going to wipe it off with a piece of the toilet paper. It really does work well because, you know, you just never need a full-blown paper towel sized thing for working for small things. So this actually works really well. So let's get back into the microscope view. To work on things this small, you really do need a microscope. At least I would say you do. If you can do it without, then you know, good for you. That's incredible. But I'm gonna zoom right the hell in. And I'm gonna focus probably. Much more better. So essentially we're going to do the same sort of process, but I'm also going to show you some, but we're going to kind of illustrate the importance of having a hot air station if you're working on stuff this small. So at this point, your soldering iron genuinely needs to be incredibly small in order to even be at all useful. So this is a pretty standard tip that I'm on this Hako station. I really could use a micro pencil, but I can't use it with this particular station. But just to give you some comparison in size, this is my soldering iron tip now. And as you can see, it's much larger than any of the components in here. So the way to work with this really is lots of flux, and you want a kind of appropriately sized tip for the surface mount parts that you're working on. Again, this is a pretty gigantic tip, but it's a lot less important with hot air tips than it is with the soldering station, because it just is. So let's say that we're going to replace that top row of resistors. Well, there's a couple of things we could do, but if we were to do the solder blob type of thing to try to get them off, these pieces are so small they would float right into the solder, and then we would never find them ever again. Which is okay if you have the parts on hand, but if you don't, then you're just kind of screwed. So I'm gonna put a nice generous blob of flux in this spot, enough to really kind of handle being blown away. See, I'm trying to squeeze it. Oh, yeah. That's way more than I need. Way more. I'll just put it on this whole area here, but again, more flux is more better. So here's another situation where I don't want to use the full blowing power of my part, of my hot air station, because it will blow those parts right away, and I'll actually show you that here in a second. But realistically, I mean, it's basically the same process as before, except now you are incredibly reliant on your thing. So I'm going to kind of do the thing where I go around, and as you'll see, the solder paste is going to become clearer, so it's going to be much easier to work with. I'm just trying to minimize that shock. Alright, I'm going to pick the part that I want to take off. I'm just going to hold on to the sides. I don't need to hold on to it very tight, but then I'm going to bring the hot air in. It can be helpful to hold it sideways like this, but it's not necessarily all that necessary. So just kind of heat this up until you see the solder start to melt, and then just plug the part that you want off. See? Just like that. We're going to do the same thing with the others. Alright, and now, come on. It's so hard because I'm trying to do this looking over my shoulder. So you really don't want to cook the board like I'm doing right now, guys. I just cannot see it without the microscope, and I can't I can't see it without the microscope, and it's difficult looking over my shoulder. Anyways, though, so we got those off, and as you can see, it's a little bit. Let me turn this light off. You can see the little thing there. Let me bring in another outside light. So if we look at the light from this side, you can see it's nice and clean. we're just going to do the same thing we did before. We're going to just do a solder blob over the top of that, and we're going to make it nice and clean. But I just want to show you, look at the size of the parts now. Like how genuinely small that is. They're sticking all over the place. Genuinely the kind of stuff that gets blown into your air filter and then you never find it again. Let's actually compare it real quick to the existing, or the bigger parts that we were soldering before. See that? But as you can see, this is about the time where you really genuinely just about have to have a micro pencil, or you need a hot air station. So that was fun. Let's do the, where am I? Okay, there we go. Let's clean this up and then place some components back on it. I'm gonna again go the whole isopropyl alcohol route and try to clean off some of the flux and those little parts that I can't hardly even see. So do. But yeah, I mean, it's basically working on the smaller parts is basically the same thing. You just kind of have to get your hand a little bit steadier than you used to, and then we'll be good. So I'm going to just grab my soldering iron, and even with the comically large tip here, I'm just going to go across all the pads together. And since I have lots of flux, it's going to suck the solder onto the pads, and then that will be good. You can see the parts here. All right. Kind of get a little bit of a solder blob into that via point, but that's okay. We're just going to scrub back and forth. We're going to clean off that not so good non-lead based solder. All right. And I'm not even going to bother doing the solder wick. Well, fuck it, I will. Let me cut off that excess, guys. Hold for a moment. But yeah, honestly, when you get to pads this small, I tend to just flood a little extra solder on there, and then it will suck away most of the bad solder, and then we'll be good. But I'm going to just go right over the top. And do you see how the braid kind of stuck to the pad for a second? That's why we lift that separate. So I'm just going to give a little tiny bit of solder now, like that. I'm going to rely on the flux that's on the board, and I'm going to drag like that. And as you can see, I left nice, minor, small little pads. Maybe a little bit more on that one. There we go. And then that just left those nice and prepped and ready to go. So I'm going to use this opportunity to show you a little bit of a trick. So again, you don't want to fry the part of the board that you're working on, because I mean, especially when you see tiny little capacitors like this in little arrangements like this, a lot of times you've got something like another chip on the other side, something like that, and if you overheat it, you can fry the chip, and you don't want that to happen. So What I'm going to do this time is I'm going to just kind of stick them on there very roughly, with a little bit of hot air to put it in place. But I'm not going to go too crazy about its position. I want it to be kind of in the right spot, but I want to rely on the surface tension. It's funny, speaking of surface tension, so I pulled this out of the rubbing alcohol, and you can just see that it's a little surface tension holding that rubbing alcohol together. So I'm actually going to position stuff a little bit better with another pair of tweezers. So I'm going to kind of get in here and get very precisely positioned. Alright, and you see how the rubbing alcohol kind of helped put it in place. So once you get to this small, you're better off poking. And just poking and then positioning and using, see, just the surface tension from that rubbing alcohol is helping suck it into position. Alright, so now I'm just going to come in here and do this over my shoulder, which is not very fun. Alright, now I'm kind of ready to go, so I'm going to get my hot air station out, and I'm going to try to place it on this pad right here, this set of pads right there. And this is ridiculous doing this over the shoulder, by the way. Alright, you see it flow into position a little bit? That's great. I'm not going to go too crazy with that though, because I want to heat the area as little as I can. If I had a micro pencil, I could, for instance, prioritize putting the part on just one little side and go at it. All right. Yep. There's that. All right. And I'm just kind of trying to flip it gently. Here we go. So here's where things start to get a little bit difficult. You see, because we're All right. So you see it's just kind of stuck there in place just a little tiny bit. That's okay, because again, it'll flow into place, and we don't want to heat things too much. And now if I can find the last of the components. Oh, yep, there it is. The rubbing alcohol. Alright, so see how this one just kind of flipped up inside the thing and it's getting stuck? I'm just going to come in with another pair of tweezers. And we're just going to try to reposition this stuff a little bit. Oh, you motherfucker. Alright. Just takes a little bit of patience. There we go. All right, let's see how well the surface tension will suck these into place. And we're doing, again, we have our air down on low because we don't want to go too crazy. Let's give this one a little bit of a push. Probably should be leaving well enough alone, guys, but I'm just gonna. Okay, so now I'm just going to kind of slowly heat the area with the air down nice and low. Maybe even a little lower would probably be good, but as soon as we start to get this melted, it's going to flow into place. Except for that one is going to fuck off on us. Alright, you see how it's kind of wiggling? Alright, so I'm going to, I heated that a little bit longer than I really should have, but I'm going to give this a good plastiflux. Right. And this should flow much better into place now. All right, where's that? All right. Okay. But yeah, so you can see it's basically the same sort of procedure. These, I really did kind of cook this area, and that's really not the best thing in the world. But it gets pretty hard once you get down to sizes that are this small, but most of the stuff that you probably end up working with are going to be things about, let's see if I can get something in shot here, this size. So, as you can see, much more better. But, yeah. Anyways, I hope that you guys found this informative. I think that I'm about ready for sleep, guys. Just tearing a random component off the board. Why not? Just sort of a test fun board anyways. But yeah, so this is kind of, you know, just, it takes a little bit of practice to get used to working with little components, but other than that, I mean, it's basically the same sort of stuff that you're doing on through-hole components, so try not to stress too much about things and just enjoy yourself. And I will talk to you guys later.